Hello everyone, my name is Fernando Gonçalves. I'm a surveyor and I'm also a civil 3D trainer. I'm working here at Toposférica, that is a Portuguese surveying company. I'll start by apologizing for my poor English. Let's hope it's enough to carry on this session. Today I would like to present a subassembly that I created in Subassembly Composer called earthworks. It is a subassembly that intend to help to measure earthworks quantities, especially in the case that you have a survey of an earthwork progress and you need to calculate volumes against the project itself. To better understand this, I have here in my presentation through two cross sections. I have a green line that represents the existing ground. I have a black line that represents the project, and I have a brown line that represents the survey earthworks progress line. I also have a hatch that represents the area that I intend to measure. As you can see in the top section on the left side, we have a case where our survey is behind the project line, and typically the quantity should be by the project line. By the other end, in the right side, we have a situation where our survey did not go to touch the project line. And also here we have a situation that we need to deal with. On the bottom section, we also have another situation here where the surveying daylight is very close to the design daylight. So in this case I would like to consider the design daylight as the line to be measured. Well, I believe that most of you guys that work in earthworks project and need to take these progress surveys have debate with situations like this and how to solve it. Most of the times we go by editing surveyings or editing the sample lines to achieve a solution, but that is very time consuming. I propose a subassembly that I created in Subassembly Composer that is able to analyze and correct those issues. Let's jump to Civil 3D to see how this works. Well, here on my screen, as I was saying, here in my screen I have a roadway project. I have some surfaces, beginning by this one that represents the existing ground. And is represented in the plan view only by its contour, and you can see it here in the tool space with the name EG. After that we have here also a corridor model of the road. From where I have created a surface corridor that is here in our tool space as FG finish ground for finish ground. Finally, we do have the earthworks update progress survey. That is this one here that is represented by contours, and it is here in my prospector with the name survey earthworks update. On the bottom window we have some cross sections that represent the area of interest of this project, meaning there are not here all the sample lines, just the ones that are in the worked area, just to exemplify. In our cross sections we have sampled the existing ground that is here with the green line, the design surface extracted from the corridor that is here with this red line, and the survey that is represented here with this blue line. Okay, let's analyze some of the sections and some of the problems that we need to deal with. We can start here at section 300. It's a typical situation where it's a cut situation, nothing special about this one. Let's move on. Here at station 320 we have one of the situations that I have spoke about. This daylight that I have surveyed is too close to the project, so in this case I intended to consider the project line, not the surveyed line. Another case, it's here. The survey crew didn't pick the daylight, so I don't know what is here, so I need to have some solutions to treat this. In this case I do believe that they didn't pick the daylight because it's very near to the project and should be considered as the project line. Let's look at another situation. Here my survey daylight is behind the project line, so I don't want to measure this quantity. I want to limit the quantity by the project line. And perhaps this one here. Okay, here I have another situation where the survey crew didn't pick the slope or the daylight, but in this case I'm too far away from the design line, so I believe we need to do something here about this situation. Okay, we identify some of the problems. Now let's start by creating an assembly that we will be using to import the subassembly that I created. Okay, let's create a new assembly. The name is preset to update earthworks. Let's just leave it like this and skip the defaults. I'm going to pick a place to put my assembly. Okay, now I'm going to bring up my subassembly that I already imported to Civil 3D. In my palettes I have here a custom palette, and my subassembly is called earthworks. Let's bring in the subassembly and let's attach it to the assembly. This is a central subassembly, meaning that is neither left or right assembly, but it works for the left and for the right. Okay, let's take a look on the parameters that we have available. Let's select the subassembly and go to properties. So my first parameter is maximum distance to daylight, and is preset to 1 meter. Well, what does this mean? Let's see. On this case, this is a good example. In this case my survey ends before intersects the project line. But the distance is a little too much to consider this as being executed, as consider this as being the project all the way up to here. We have another situation here. This one is a good one. Here we have the same case, but we are much more close to the final daylight. So this parameter, the maximum distance to daylight, will we'll set the distance that we should consider to project our survey to the design daylight. In this case, it is easy to see that is inside the perimeter distance is inside, it's minor than 1 meter, so it will project this slope up to this point and then consider the daylight. In this case, that is too far away, that is more than 1 meter, and I do believe, let's draw a 1 meter circle here. Yeah, it is more than 1 meter, so it will perform differently. And what is going to do, let me select the subassembly again. If it is beyond the maximum distance to project to the daylight, it should create its own daylight. And to do that, I have here 3 different options for the daylight type that it will be created. The first option is equal to design, and it will take the daylight that is closer, the design daylight that is closer to the final point of the survey. In this case, this one, it will pick this slope and apply it here as a parallel daylight. Another option available is user defined, and by this I will specify on the 3rd and 4th parameters the slope that I want to use in fill and in cut situations. Finally, I can also set it as vertical. For now, let's just leave it as equal to design. The last parameter is auto correction distance, and this parameter that is set here to half meter is to be used on this type of situation where we have the survey too close to the final design and we have the daylight surveyed to and at least 2 or 3 points in the daylight are too close to the final project, and I want to consider this as being or be measured by the final project line. So this is the distance that will define where or when should I consider my daylight line as final project. In this case is set to alpha meter. Let's see what will happen in this cross section later. Let's draw a circle with alpha meter. And yes, it's slightly inside of the perimeter. So in this case, I can assure you that it will correct the surveyed daylight to the design daylight. Okay, this is all for the parameters, but besides that, this subassembly needs to work with some offset targets. To work correctly, she will need to map the limit of the design on the left and on the right hand side, and also need to map the limit of the survey on the left, so this line here, and on the right, and this line here, and also in this side the same thing. I didn't talk about this one, but our survey is divided in 2 areas. This one is a fill region, this one is a cutting region. This sometimes occur, and I use this survey because to show that the subassembly also can deal with a surface, a survey surface that is not that is separated in 2 regions. Okay, to save some time, I already have extracted the polylines that I will use as targets, at offset targets. I have them here on a layer that I called limits, And well, as you can see, the green polylines are the limits of the survey, and the magenta polylines are the limits of the project. So now we are ready to create a corridor. So let's go to the home ribbon and corridor to create a new corridor. I'm going to use this name that came per default, earthworks update. Leave the defaults. Let's just pick the right alignment, that in this case is route 02. And for the profile, doesn't really matter, so I'm going to leave this one. For the assembly, I will use the one that we created before, the update earthworks. And as a target surface, I will not specify now. I will, yes, set the baseline and region parameters. And let's go. Let's start by specify the start and end station. We don't need to perform this calculation for all the corridor or alignment. Let's start here and let's go, let's say, up to this point. This will cover all the survey area. For the frequency, it's very important that your corridor sections match the sample lines, or at least for each sample line that you have, you need to have also a corridor section. So my sample lines are each 10 meters, so that will be the distance that I will use as increment in all situations. So the frequency is set. Let's go to targets now. This surface, this corridor needs to map 3 surfaces. The survey itself, that here is my survey earthworks update. The design surface, that is here my finish ground FG surface, and the existing ground surface, that is my EG surface. Besides that, it needs to target the offsets that we already talked about. So starting by the left survey limit, I'm going to select them from the drawing, and should be this for the survey, these 2 green lines on the left. And for the right, I apologize, I didn't explain my alignment starts here. This is the station 0, that's why this is left and this is right. So for the right limits, these ones. Now for the design left limit, selecting the drawing, my magenta left line, and for the right, the same thing. Okay, I'm ready. Let's continue. Let's push OK to calculate the corridor. Building this corridor will generate many errors. That's due to the way that the subassembly works and tests every possibility, and some of them are not even possible to be tested, and that will generate those errors. Well, anyway, don't worry. This doesn't mean that the subassembly is incorrect. Let's check here on the errors. I'm going just to dismiss those errors. Okay, on my plan view I can see the representation of my corridor, which is a little odd, but well, is how it works, and it is working correctly. From now on we can create a corridor surface, and that's what we're going to do. Selecting the corridor, going to corridor surfaces, let's add a new surface. I'm going to call it final surface. I'm going to leave it as a no display, with a no display style. I don't need a plan representation. I'm going to add some links. The only links that I have available are top links. So I'm going to add the top and I'm going to add them as break lines. Very important to have a boundary. I added a special point code that will create a full boundary automatically. So let's right click on our surface, add automatically, and here is my point code that enables that boundary. That is LMT, that means limit. Okay, all set. And here is our just created surface, the final surface, and from this point we can throw this surface to the cross sections. Let's select one cross section, use the sample more sources button, and let's add the surface that is this one, earthworks update final surface. Add. I'm going to pick here a line style that will be easy to recognize, this orange line. Okay, and there she is. I'm going just to select them all by select one and select similar, and send this line under everything else. Like this will be easier to see the result of this new surface. Well, let's check the cross sections, and let's start by the first cross section where we don't have any survey line. And what this subassembly does, or creates, or this surface is created, it creates a new surface that starts from the left hand side of the project limit through the right hand side of the project limit. In this second section, we the same happens, but we have a little bit of survey here, and the new surface will follow the survey where he is. The third cross section is pretty much the same thing, and the fourth cross section will have the same situation on the left, but on the right we are on one of the cases where our line is too close to the final project line, and so my final surface is now following the design from this point, as you can see. So this is due to that parameter. Let me show you. I'm going to select subassembly again. This is due to this parameter, that is the automatic correction distance that is set to alpha meter. Let's reduce this to just 10 centimeters just to see what happened. We'll need to rebuild the surface, the corridor, sorry. Let's right click and rebuild. And as you can see, by changing the parameter, now we are away or far away from the 10 centimeters limit, and now we are following the surveyed daylight up to the existing ground. Let's go back and return the same value to this auto correction parameter and rebuild again. Let's see other situation. In this situation, we are close to the survey ends close to the design line, and it extends automatically to the design daylight. Here we have the same situation, and finally here we have another situation where my survey ends too far away from the daylight, the design daylight, and in this case I'm using the parameter that is set to copy the design daylight slope and create a new daylight beginning from the end of the survey. Let's see the parameter here on the subassembly. So the parameter that determines whether should I extend or not the survey up to the daylight is this one, is the distance to the daylight. In this case is set to 1 meter, and once I'm beyond that distance, it will create me a daylight as we have spoke before. So now I'm using the option equal to design. Let's change this to user defined to see what happens. And once I'm here in the cut situation, let's say I want a 0.5 to 1 daylight. Let's rebuild, and here I have a 0.5 to 1 daylight. This solution will be applied for all the daylights that are in the same situation, as you can see in the next cross section. We also can, let's select again the subassembly. We can also use the vertical solution. Let's rebuild, and there we have a vertical option to solve this incomplete survey. Let's put it back to the default option equal to the design and rebuild. Most of the other situations, well, except for this one is also relevant. As you can see, here is one of the cases that the survey is beyond the design line, and what is happening here is that my final surface is getting the intersection point in between the survey and the project, and is following the project from this point. All the other cases are similar to the ones that we have seen so far, only that in my final sections I have a fill situation, and where you can see that it's working the same way. Well, once everything is looking good, let's perform a volume calculation to see if the areas are what we intend to. To do that, let's start by picking one sample line. Go to group properties, and on group properties, let's go to material list, and let's import another criteria. Well, I have some few criteria here. I'm going to use the cut and fill criteria that will ask me to map an existing ground that here is typed in Portuguese, but well, this is the existing ground. That is my EG surface, and this one should be the design surface. But that in this case, my target is not the design surface, is the modified survey surface, that is the earthworks update final surface. Okay, this material list performs a cut and a fill material independently. Let's call this material list earthworks, and let's compute it. Let's check the cross sections, and I do believe that everything is as it was supposed to be. Yes, no doubt. Just for a small detail. Let's see, for instance, this cross section here. Well, as you can see here, my survey line is already on the middle of the section, or on the middle of the surveyed area, is already above my design line. So this area here should not be considered. How can we solve this? Actually, it's pretty simple. Let's go to our material list again, group properties, and we can do this by adding the design line to the calculation. So let's pick our finish ground, that it's road 02 FG surface, and let's add it to both fill and cut, and they should be added in the same place that is our survey line. Well, in this case our survey line is above, so our design line should be also above. In the fill case, the survey line is below, so the design line should be also below. Okay, and as you can see now, the calculation is exactly as it should be. I think we have also here a case in cut. Yes, it's here, and as you can see, this portion of the survey is not being considered, is limited by the design line. Well, and that's all. This is the subassembly earthworks that is able to deal with this type of situations. I hope you found this subassembly useful for your daily work. I'm not going to show the subassembly in Subassembly Composer because it's a very complex subassembly. It will take me at least 2 hours or 3 hours to explain all the subassembly. In case you are interested, I can pass you this subassembly by email. Please contact me by the email that you can see here, or by the phone number that you can see here. We also provide some other type of services. If you are interested in get your own subassembly, your specified subassembly, a subassembly that meets your own unique requirements, please don't hesitate and contact me, and I see if I can help you. Okay, hope everybody enjoyed. Thank you very much. See you next time.